Hi everyone, and welcome to our video on converting rectangular points into polar form. So we left off on the last video showing the breakdown between the connection of x, y, and r theta, where it really is SOHCAHTOA and Pythagorean's theorem. And then we used that information to help us create this scenario, which helped us convert from polar to rectangular. So that was these problems. Now we're going to convert rectangular to polar, which will eventually give us these here. All right, so let's break this down. I'm still going to start it with a sketch. So convert the following rectangular points into polar form. All right, so this first one I'm going to sketch right away. So -16 to the left, -16 would be down, and then we're here. Okay, so that's plotting the rectangular points. There's x comma y. And then we can make that if we want to. And what we need is this angle and this. Let's go ahead and put that in blue. That link there, R. But we can see, oh yeah, it's a special triangle. Okay, so where those are 16 each, if I'm just looking at a triangle. So this is a 45, 45, 90 triangle, and we can use those properties to get it, which means I could just multiply this by the square root of 2. So one of the legs times the square root of 2 would be the hypotenuse of that triangle. It would be the radius. Okay, so that means we do have it. Okay, so I have R, so that is R. And then, well, again, if I know that that's a 45-degree angle, and if I'm measuring something in standard position, I have a 45-degree angle in the third quadrant. So that means this right here is 45. And I have a straight line already. I know that this right there is 180. So 180 and 45 is 225. So we would know theta is 225 in degrees. Now, typically they do radians, but just connecting these two, we do have our answer. So this one I was doing purely by a sketch. So our R is 16 square root 2. Our theta is 225 degrees. Now, again, they usually do radians, so I just want to do 1 in degrees. The R is still the same, and then the radian measure would be 5 pi over 4. Okay, so we can convert it real quick as well. Okay, so that's using the picture purely on its own. All right, if we wanted to try to jump into our point using the form, so R and theta, so using our clouded ones from up there, we would have, well, plus or minus square root of x squared plus y squared, comma, and then we just did theta can get solved for by doing the tangent inverse of y over x. Okay, and if we do plug those in, we'd have plus or minus x squared is -16, getting squared, plus y squared is also -16, getting squared, comma, and then tangent inverse of -16 over -16. Okay, and then if we were to simplify that square root, it would be plus or minus 16 square root of 2. So I'm going to skip that 16 squared plus 16 squared and simplifying for this problem, so because we already have it. For the next one, we'll break it down further. And then this is the same thing as tangent inverse of 1. I'm going to put that a little to the side since I'm a little off. And here's where the tangent inverse might not be the best, because if I did plug that into a calculator, it would say -45 degrees. But tangent, oops, it wouldn't say -45. Sorry, I was looking at the two negatives and not seeing the positive. Let me erase that. Tangent inverse of 1 in the calculator would give me positive 45 degrees if we're doing degrees still. But we know tangent is positive also in quadrant 3. Okay, so then that is 225 degrees. So we would need to choose the correct one dependent on the plus or minus. So if I'm choosing the plus, then I would want to choose the 225 degrees to match the answer that we got first. If I chose the negative, So let's go ahead and just squeeze that in right here next to it. So if I chose the negative radius, then it looks like I could choose the positive 45 degrees. Because again, remember on our sketch, let's just plot it right now. Here's where 45 degrees would have been. And then that means the positives would have been going along toward the 45 degrees, but we need to go the opposite direction, which puts us over where I'm making my big old bolded dot. And that's why our radius should be negative in this case. So when we convert from rectangular to polar, we can have different answers. Okay, and this one again, we can convert to radians if we wanted to. Okay, so the answer is not unique on these. However, usually we prefer a radius that's positive with an angle that's on the unit circle from 0 to 2 pi. All right, anyway, let's try this number 2 now. Again, this is an x coordinate and y coordinate. I think I'll do the sketch second. All right, so the way I'm going to look at this is I'm going to go ahead and say, oops, our r and theta would be plus or minus the square root of x squared plus y squared, comma, and let's do the tangent inverse again of y over x. Again, I think the picture can help a lot, but I think this is good for if the numbers aren't as nice. So I'm just plugging stuff in for if they give us worse numbers. All right, and anyway, we would have plus or minus x is -7 getting squared plus y is 7 radical 3 getting squared, and then comma, tangent inverse of y, which is 7 radical 3 over -7. Okay, and then now we're looking at the rest of this and trying to solve it or trying to simplify it. So I've got plus or minus square root, -7 squared is 49, and then plus 7 squared is still 49, times square root of 3 squared would have been 3. So I do need a little scratch work. It would have been 49 times 3, and that gives us 7, and then 3 times 4, 4, 8, 12, and 14. So 147, comma. And then notice in our tangent inverse, the 7's cancel, and I would have a negative radical 3. Okay, and then now still simplifying, I have plus or minus the square root, 49 plus 147. Okay, let's do that right there. So 9 plus 7 is 16. So we get 196. And then still tangent inverse of the negative square root of 3. All right, well, square root of 196 is a nice number. It is 14. So we have plus or minus 14. And then tangent inverse of negative radical 3, well, we can use our unit circle for that. It would be in quadrant 2, close to the y-axis, or 4, close to the y-axis. So again, we choose the angle based on these problems. And you might say, if you've been following along with all the videos, like with inverse trig from a while ago, you might say, shouldn't there only be one answer for inverse trig? Yes, but in our scenario, we started with a non-inverse trig problem. Okay, and we just plugged it in for this to make it kind of more compact. So this is a tangent equation that has multiple answers, where we're just simplifying in the form, but we still think, oh, go back to the tangent that could have multiple answers. Okay, so that means I need to choose between, let's do our radian measures. It would be 2 pi thirds or 5 pi thirds. Okay, so from rectangular to polar, we've got more options to make, or more choices to make. Whereas polar to rectangular is straightforward. Those ones are nicer. All right, anyway, and these ones aren't that bad. We just have to double check some things. Well, anyway, I said I wanted to do all the math first and then plot it this time. Okay, so a little crowded. Sorry, I'm gonna plot the point right here real small. So -7 to the left and then up 7 radical 3 would put us in quadrant 2. So all I want to do is make sure I choose the correct values here. I'm going to choose the positive radius, and then I'm going to choose the angle that's in quadrant 2, 2 pi thirds. That's it. Okay, so that's why it might be better to plot right away instead of jumping to an equation, but you can go in any order. I would say no matter what, always plot. All right, so if these numbers were nastier and we did need a calculator, the calculator would have given us the angle that's in quadrant 4 as a negative. Okay, so it would have given us the negative pi thirds. So we could say, or negative pi thirds. And if I wanted to say, well, if it's negative pi thirds, but I want to be in quadrant 2, I should choose the negative radius. Okay, so this is a different answer that we could have gotten. That is putting us in the same spot. Okay, so if we are stuck with a calculator problem, say it's some weird decimal answer in the calculator, well, then we can still figure out what we should make the sign for the radius if we make a quick sketch. Okay, that's that for now. Thanks for watching. If you do have any questions, please let me know.